Okay. Define simple harmonic motion as the first one. So does anybody remember what we need to have simple harmonic motion? Huh? B3. Yeah. Siba, do you remember? What do you need to have simple harmonic motion? Huh? Ah yeah, but give me a sentence, the definition. Simple harmonic motion is motion. No, let's use good English. An object is undergoing simple harmonic motion if, so number one, there's a force proportional to the displacement. And number two, anything else special that you need about the force? It has, so a bigger displacement means a bigger force. And what about the direction of the force? Force is opposite in direction to displacement. And the last thing we should say is force is towards the origin. So in other words, if this is the origin and here's our object and this is our displacement, then the force is that way. And this force is proportional to the size of the S. Am I thinking that everybody is thinking, I'll just lose the 2 marks. Seems too much work to learn and write this.
What is B1 and B2?
Huh? Is B1 mechanics?
Yeah,
Oh, I see, sorry, you said you just solved B1 and B2 instead. What about if it came up with section A? Right. Part B now. Part B. A spring hangs from a hook, mass 200 grams, and this causes the spring to extend 48.6 millimeters. Show that the spring constant is that. So this is the one, you know, where you have something hanging from the ceiling, you put a mass on it, and then it stretches down. What formula could we use to get the K? Yeah. Yeah, you seem surprised that you knew it, what?
What's the third one?
Force towards the origin. Continue? Yeah. So part B. Give me the info, please. How much is the mass here? 200 grams, is it? And this then causes it to extend how much? 48.6 millimeters. And that's all you know, isn't it? Okay, so there's 2 forces here. The weight, which is 0.2 times G, and then Hooke's law, which says F equals K delta X, which in this case is 0.0486. So you have 0.0, okay, let me just write here, 0.0486 K equals 0.2 times 9.81. So K is 0.2 times 9.81 over 0.0486 which equals 40.37 newtons per meter. I hope. Is it?
Yeah.
Please tell me if it's not 40.37.
It is, but I got to, I did it round, and I got the same answer.
Oh, okay. What do you mean you didn't round?
I didn't, I put 200, 200 G.
Yeah. What's happening? This is 40.37 if you type it in, right?
The
Right.
way the scheme says that.
Ah, yeah, but we can't trust that. We should trust ourselves. Is it 40.37? There we go. Okay, continue. C. So does anybody remember the formula here? What's happening is, here it is in equilibrium, then somebody comes along and pulls it down even more, and it starts to bob up and down, up and down, up and down. So the question now is, what's the periodic time? Does anyone remember the formula? You just saw it there in the marking scheme, yeah? Ah, do you remember it? Okay. I'll get you started, maybe it'll help you remember. There's a 2 pi, yes, good. The next part? There's a square root, good. Ah, no, that's the pendulum. That's the pendulum. We want the spring.
A.
No. Oh no.
K.
There's a K somewhere in it. M over K. So that's 2 pi root 0.2 times 9.81 over 40.37.
$1.385.
Thank you. Okay, part 2. What's the frequency? Who remembers the formula for frequency?
No,
One
T.
over T.
1 over t. So 1 over 1.385 equals
0.722.
and the unit?
Yes.
Okay, part 3. What's the maximum velocity? So does anyone remember the formula for simple harmonic motion velocity? It's v equals, or what is it? Yeah, there's an
A.
omega square root a squared minus x squared. But we want the maximum velocity, omega a, because, yeah. Do we have omega? We don't. But what's the formula for omega? You could use the 2 pi over t, couldn't you? Because you have t is 2 pi over omega. So omega is 2 pi over t. Oh, do we know the amplitude? It says it in part C at the beginning. I didn't draw it in. Here, the boy pulls it down a distance of 7.5 millimeters. That's the amplitude. So here we have to multiply this by 7.5 times 10 to the minus 3. Okay, so we get an answer here for V max. 0.034 meters per second. Part 4, when will the maximum velocity take place? Maximum velocity happens at the equilibrium, the origin, yeah. Part 5, what's the maximum acceleration? So you remember the formula for acceleration equals minus omega squared x. So what's the formula for the maximum acceleration? What's the biggest value you could have here? Yeah, minus omega, well, make it a plus omega squared a. So again, the omega is 2 pi over t squared times 7.5 times 10 to the minus 3. So that equals
0.155. No, 0.154.
okay. And when will the maximum acceleration take place? It's at the same place the maximum force takes place because F equals ma. So where is the maximum force taking place in the motion? So in its motion, where's the maximum acceleration? The ends, yeah, yeah. So in other words, actually at the start, at the beginning, when the boy pulls it down the full distance and releases, that's the maximum acceleration. Right, so we're already nearly finished. We just have one part left to do. But it's a hard one because it's 5 marks. Yeah. Can I scroll down to it? Because I'll need a full screen for it. Yeah, I can scroll down? Yeah, okay. So, here's the picture. There's the equilibrium. And the boy pulls it down, what do we say, a distance of 7 millimeters, I think we said? Yeah, no, 7.5. But was I using 7 or 7.5? Oh, good, 7.5. 7.5 millimeters. And then it goes up, and then back down, and so on. Repeats like this. Okay, well anyways, let's just read what they want. The time to move from 4 millimeters above to 4 millimeters below. So they want the time it takes to go, and the key word is direct. Okay, because there's 2 ways you can do it. You can be, let me just mark it off here. That and that are 4 millimeters. So the 2 ways you can do it is you can be here, you can go up and down to 4, from 4 to minus 4. But that's not quite what they want. They want direct time. So that would be when it's here down to here. That's what they mean by the direct. So what we could do is we could find the time it takes to go all the way up and down to here. Then we could find the time it takes to go up and down to here, and then minus the 2 times. Now, we'll call this side plus and this side minus, because remember, for the simple harmonic motion, it's easier if we start in the positive. We have 2 formulas for x, a cos or a sine. Who remembers which I need here, cos or sine? You had a 50-50 chance. And do you remember my trick for remembering? Cos has an O in it, and O stands for outside. Starts on the outside. Okay, right. So let's look at this time to here. What's the x? Well, the x is minus 0.004. What's the a? The a is 0.0075. Yes? And then we have cos omega t. Let me just write it over here. More space. Minus 0.004 equals 0.0075 cos. Can somebody actually work out the omega? Because I keep using it. 2 pi over, what was the time? 1.385. What is that actually? .536. Now let's get the t here. Make sure your calculator's in radian mode. So the t would equal cos inverse minus 0.004 over 0.0075 over 4.536. Seconds. Yeah? But there's a small problem. You know from maths class that cos has 2 answers. Yes? Because you have 2 possible answers here for cos. I don't know which way Joan taught it to you. Maybe she showed you the circle. Yeah? Now we're in the negative because we have a minus here. Okay? So that means we are, we can't be here. We must be here, or we must be here. Right? Because we know cos is a negative. So that's 0.47 seconds. That's either going to be having us in the second or the third quadrant. How could we work it out? Before you divide it by the 4.56, that would have been about 2. Do you still have the answer before you divide by 4.536? What did you get?
So 100.
Radians.
Oh,
Radians. Well, actually, no, that's okay. You said 100. So it means I'm in this quadrant, the S quadrant. So how can I get the second answer? Add how much? 90, but we're in radians. So what do you add for 90 degrees if it's radians? Nearly pi over 2. So can you just add pi over 2 to this answer, please, Siba, and we'll get the second answer. .04 seconds. Okay, now we have to repeat all this, but now for this one. But we don't have to change much. What is the only difference if we were to get the time from here to here? What's the only difference? What's the only thing that's different in this equation? Is the amplitude the same?
Minus 0.004.
Yeah, it's now what?
0.
It's no. Well, actually, my picture's not great. It's 4 millimeters.
Less.
So
Okay.
so it's a plus now instead. So in fact, if you just go back on your calculator and change this to a plus, we can get the second answer. So that's actually T1. So then T2 will equal .222 seconds. Now we have to get the second answer. Okay. So because we're looking at positive, which quadrants are we in? Yeah, A and C. So because this is so small, it's going to be the first quadrant. So how do we get the C quadrant answer? What do we do? We can just do 2 pi minus the first answer to flip it around to the last quadrant. So see, if you type in 2 pi minus this, see what we get. 0.06 seconds. Why did we get 2 answers for each? Well, let's look. Look here for the first one. the reason for the two answers is because what you've actually worked out is the time to here and to here, because they're both 4 millimeters from the equilibrium. So in this question here, which time do I take, the first or the second time? No, the second, because remember we want to go from here directly down. So we take the bigger time. Okay, and for the next one, the reason we have two, why do we have a really small one and a really big one here? Well, the really small answer represents the time to go from here to here, which is at -4. And then the really big one is the time to go from here up and down to here. So which one do we take? First or second? Oh, second. Because we want to go to this one. So my final answer would be 6.06 minus 2.04, which is 4.02 seconds.
So
Yeah. Don't tell me I made a mistake. I can't bear having to recalculate this. What? Is it a mistake?
I don't know
Okay.
if you cos -1
Yeah.
and you got the radius, then you
Divided by the
then you
4.536.
find the second answer. You divide then class first then divide.
Oh, very good. Maybe I have the order the wrong way around. Let me think about my maths for a moment. Okay, that's not a big problem because I can easily fix that. What did you learn in maths class? Thank you. Sorry. You know when I was asking you to add the 2 pi and the minus pi, as Matt pointed out rightly, we should have done that before divided by 4.536. So I'll just fix that up here. You'll need to type in cos inverse minus number, and then for what did we do here? We added pi over 2, wasn't it? And then divided by 4.536. And then here we have cos inverse the positive number, 2 pi minus that over 4.536. That's what you're saying. That is correct. Can we recalculate that? Siba, can you do the first one, and George, can you do the second one? The plus is this number with the plus.
I have the first one.
You have the first one, what is it?
0.82.
0.82 seconds. Okay. And then the second one.
Minus 11.35.
Whoa, minus, me no like. It's possible you typed it in wrong?
Got 1.16.
Ah, that makes me happier.
1629.
1.163 seconds. And then just finally minus these two to get the answer at the end.
0.34.
0.34 seconds. What's the answer in the market scheme there? If we can check. What's
He's
happening?
getting negative 11.
Tell me what you're typing in, man. Oh, it's gone. Okay. Make me happy, Siba. Tell me that's 0.34. Don't break my heart. Don't break my heart. What is it?
0.07.
Add Siba. Why do you have to do this to me? Show me. Show me. .0792. Oh. Maybe they're wrong actually. That's nice. possible anybody typed in and got one of the wrong numbers? Is that possible? Hang on. Who gave me the time earlier? Who told me the time? Because I see the answer with the time here is different to what I got. Could somebody retype that in, please?
Which one?
1.385.
1.385. I'm sorry, it's locked. Could you unlock it, please?
Are there?
No. No. I'm wrong. Oh, it's a disaster. What did I write wrong here? It's terrible. Come on, I'm not letting you go to lunch until you tell me my mistake. What's wrong in this line? No, it's not, it's, the formula's right. The formula's right. One of these numbers is wrong.
The 2? We have to divide it by 2?
No? No?
2 by 3 is that?
Come on, one of my numbers is wrong. Which number is wrong?
0.2?
There's no G. There's no 9.81. Yeah? So it means that this error carries all the way down. What are you doing?
Hey Stephen, I didn't know you were teaching. Are you scheduled here for this hour? I can go down
No.
below. Okay.
Oh yeah, I'm finished now. 30 seconds.
Okay, cool, grand. I'll just leave that down there
Who have you got?
then. Business.
Now I have class in here at 2.
That's fine, we're out at 2, it's a 1 hour.
Okay, grand.
Yeah.
Grand, grand. Are you doing this, is this instead of doing it later in the day?
No, no, this is extra. They didn't have EAP this morning, so, but I wasn't able to teach them because I was on PFE.
Okay, grand.
So it's,
Okay,
in.
so you all understand that the 9.81 shouldn't be there? You understand? Nobody noticed until I pointed it out. Of course you realise that T is wrong, which makes this wrong, which makes this wrong, which makes everything wrong. It's just disgraceful. It's absolutely disgraceful. And I don't know which is worse, that I made this mistake or that nobody noticed this mistake. Alright. Well, that's life. That's life.